I'm just going to delve straight into it. So most slide you see this information about me. So it's just basically part two of it. And I like this video on the side because it gives a timeline of how things have evolved, and even this is so interesting. Let's see. Let's have a look. It's got sound, it's in my ears, but there's no talking in anyway. And I personally really like it because it shows you, when they say there's an app for everything, but it shows you how far we've come, even from the size of the computer itself to even all these devices like fax, I don't know, a calendar, poster notes, encyclopedia. That's why I see pictures and other things all being replaced with an app. And even if you want to go a step further, all of these also sit on your mobile devices or mobile phones, for example, that you are using to communicate on a daily basis as well. So we can tell the world indeed has come a long way in terms of making the world a better place. And luckily, there is a mobile phone sitting at the bottom there. Pause that and also close that, so at least we have that on the way. So we're talking about multi-purpose devices. Think simply one device that have several purposes. Multi means several or many, right? So you have several purposes, one device, several purposes. So we have previously, as we've seen in the video, previously we have each one being dedicated, dating back all the way to the 80s, right? Each being dedicated device, but now we do have all of these coming together, so creating some form of convergence. When you converge, come together, right? So they come together to form the multi-purpose ICT devices or multi-purpose devices. So one device can have several tasks. And as we've discussed earlier, it's mostly driven by the power of the computing devices or the technology becoming more powerful. Like, this is a whole camera sitting at the bottom there. You have your phone camera. It's also integrated just at the back of your phone. You've got front camera even too, that you can take pictures, and so you can do processing straight away. If you don't like the picture, you just delete it, take a new one, right? So the technology is becoming more powerful. You've got high power technology devices, and also the communication power has increased. Like we mentioned about 5G, and when you Google 5G, first thing you find is around the fact that you can download a whole video in a very short time, for example. And of course, the advent of internet makes also this communication possible, and hence these things coming together with the convergence, making it way possible for the small devices or the devices we have to be more multi-purpose. So we've got some examples, but I prefer the video, so we will carry on with this. Right. And if you're talking about, it's just touching on various aspects of ICT things we are already familiar with. So if you're talking about integration of information services, previously you have things like newspapers. Now even on your phone you've got news alerts. You've got you would have dedicated TVs, for example. Now you've got iPlayer that runs on it. You will get things like Netflix and other things coming. You can even play games on some TVs as well. So more or less, this convergence and integration into a single device becoming more popular around devices that we use. Okay, so alongside joining together of the technologies, of course, there is also the tendency of integrating the common devices. So things like TV channels, radio, you can get radio on TV these days as well. You get news alerts and other things. And actually, on your phone, you can watch Netflix and other things on your phone too. So we want to think about the main stages that we use to implement a new computer system or a new information technology system. Now, I'm using the term loosely because we've already established that computers are not necessarily the same as ICT. Computers form a subsystem of the ICT, so it's a subset. So let's say you're in charge of a company, for example, and you thinking of upgrading the system there, or you've been contracted to change or give 100 computers, for example, or even you just simply thinking of changing your own computer. Okay. So first of all, you go through an analysis phase, looking at what is existing, what is there, what is needed for the current time, what are you going to use it for. So the same way before we start to talk about what kind of softwares do you need. So people ask questions about what they already have. Would it be okay to use this? I'm thinking you may be better off going for this or that. So we look at what is we already have. Then from that point, we have a clear idea of what we need to do. So we step back and then we put some designs or some things on paper. So that takes, after the analysis stage, we go through some design stage. I do apologize. Let me put that away. It shouldn't be there. Right? So that takes us through the design, and you sit down, put the design out, then you go out to actually implement the work. Like implement either buying the actual computer, opening it up, or getting all the computers, setting them up. So it's a point where you actually bring in the physical thing there for it to work. Now that the computers or the new system is in place, then you look at evaluating its performance. So first of all, we looked at what is missing. We set out what we want to achieve. We've gotten it already now. So does it actually meet the requirement? Does it do the job? Right? Do we like what we've gone for? So we look at evaluating what is there. So let's go through each of them, even though we've talked about it briefly. So I'm just going to touch on them. We're going through each of them. So basically, analysis is about how we're looking at what we have now, how we're going to get a job done. So basically, how is it being done now? Is it meeting its current purpose, or is it meeting the purpose we need to get it for? Or can we do it even better or more efficiently by upgrading it? If there is no need to upgrade, then why should we upgrade? If it's probably going to be too costly for no performance benefit at all, why do it? So there must be some form of benefit if you are thinking of changing it, right? So with this goal in mind, how do you go about by the analysis? And we're thinking about the person doing the analysis is the system analyst, right? So if someone says, I'm the system analyst, simply means I look at what is existing, see whether we need to change or not, and whether even the change is necessary. So basically, observe the staff at work, speak to people, for example. So observe the staff, interview the staff, which is the people, because there's a people element. Talk to them about how the current system is working. So basically, if let's say you want to replace the IT equipment, talk to them. Is it meeting your needs? Do you need new software? Is it fast enough? Are you able to process the information the clients need on time or something like that? And from that, you can capture the data and make good decision based on that. And normally this will involve a feasibility study. So feasibility study means it's something suitable, right? So after you do your talking to them and other things, you want to find out, is it suitable to have the new system in place? So the feasibility study help us to evaluate what we are going to put in place, or the new system that's going to replace it. So technically, is it feasible? Is it feasible to buy the fastest computers in the world, or the fastest communication equipment in the world? Is it economical? So maybe yes, feasible to go for the fastest ones, but how much is it going to cost us? So do we get a good trade-off between them, for example? Okay. Then it comes to, after the feasibility study, if there's no need to continue, why do it? You don't have to do it at all, of course. So you continue to go ahead. If you find the project both technically and economically feasible, then you can go ahead with the project of replacing things. Now we're talking about stepping back to design the system that is going to be in place, right? So to go ahead with your design after the, of course, evaluation and the analysis and feasibility stage, you're just going to sit down to think, okay, what kind of hardware do I need? What kind of software do I need? What kind of inputs or processing power am I considering? So if normally you go with inputs and outputs, what kind of inputs do I need? What kind of outputs do I need? Somebody say, I want to buy a new computer. They say, oh, what kind of speed do you need? What kind of processor? What's your budget? Right? So at that point, you're thinking of what is needed. That's when you are going through the design, and once you establish what you need, that is when you will actually go to the implementation stage. But before that, you want to think about, okay, this is what I have in place now. Is it going to meet the actual work before I go out to buy or spend money? Because if you buy all that and it doesn't work, then you, of course, you're in trouble because you've costed your company or your boss money or even yourself money, right? So you put in place a test plan for the design that you have made. So basically, how are you going to test your system? And that makes life a lot easier for yourself. So in terms of if it is a software you're thinking about for your test, you're going to input it with potentially typical data, which is the data you are likely to deal with on a daily basis, or you want to test it with an extreme data. So let's say your system, it will be 20 people managing the system, for example. You say, what if it become 100 people, for example, right now? So if, let's say, the classrooms are designed to hold only 30 students, and then suddenly we are recruiting about 120 students, how is the building going to cope? How are the classes going to be run? So if we never think about the extreme case, we are likely to come to a point where our system will fail. So it's good to think about testing your system with extreme data. And also, you need to provide some error data as well. So if you think about providing an erroneous data, so an example would be if you ask Alexa something that doesn't fall within its capacity. Say, sorry, I don't know that. Instead of Alexa crashing, Alexa has been programmed in such a way that if it doesn't know something, it tells you, I don't know that. Maybe the AI is good enough that it will try to learn from that experience once you correct it or something. But at the point where it doesn't know, is you providing it with invalid data or data that has errors. Good. So at this point, can I do a quick check? So the implementation stage, that's if it is a code, it's writing the actual program. If it is bringing the computers, it's setting up the actual computers, buying, making sure the real thing is in place, right? If it is software installation, going on with the installation and the other things. So you may need, of course, to provide some documents as well, things that help you. If you've bought anything from IKEA, you know you may have user guide, installation details, things like samples of how the output should look like. If you provide certain input, this is how the output should look like. Some screenshots, or basically things like what some error messages mean, or for troubleshooting, for example. So like old computers, they say if you try to switch it on and it beeps 3 times or 4 times, then it means like there's a problem with the memory. So straight away, you check the user guide, you know what to do. Then comes to, of course, you've gone through all the stages, you have the system in place now. How do you evaluate the output, right? So basically, you check whether everything is working correctly. We're happy with that. And also, you go back to analyze things. So before, remember, right at the beginning, we talk to the staff. No need to draw persons. So right at the beginning, we talk to the staff. We've implemented it now. We want to go back to the people to see, is it meeting what you expected? So things like going back to interviewing the staff, doing things like questionnaires and other things. And of course, after evaluating, you also want to make sure that you provide some form of maintenance for the system that's already in place. So we've already talked about computers having the soft part. We've talked about the physical part, and then of course the data that it's dealing with. So the physical things is the stuff that we can touch. Software is the one that helps the computer to work, but it's not necessarily something you touch physically. So if it's a mobile phone, your phone is the hardware, the physical one that you can touch, or even when you open it, the ones you can physically touch, even no matter how small they are. Then things that will be in software things will be like mobile phone apps, or even if it's Android, the Android or iOS is a software. If it's iPhone, of course, the OS is also a software, but iOS is a software. But things, even the apps running on it, like even Zoom, is also a software. Good. So each of them have their specific things that they perform. I will pause here and breathe a little bit just to make sure I'm not talking too fast. So we're now looking at the software. It's not this physical thing. It's not this physical thing. Yeah, things like monitor, keyboard, you can touch. Even when you open the computer, motherboard, all those things are like hardware. Like it's hardware, got a physical feel to it. But we want to concentrate on the software, not the monitor, but what is behind it, what is in the digital world. So the mobile phone itself, this is my hardware. This is my hardware. Now at the moment, I've opened an app. Whatever is in there, I can't touch the app. It's a software. It's in ones and zeros. It's digital form. It's something that the screen is allowing me to display. Ooh, cool. The screen is allowing me to display, which is just the screen is the hardware. I can touch it. But the image showing is a software. If I print this image out, it becomes something hardware. If I put the image on the wall, it's hardware. But at the moment, this image is in ones and zeros, it's software. Whatever email notifications I have is software. This news thing is also software, something that is running in the background, right? The hardware I touch, hardware I touch. Whatever is on there is software, right? Okay, so we want to see the bits that is in the digital world, like the ones and zeros. So we're looking at software, different types of software, something like word processor, spreadsheets, um, other management softwares, they are software. So now we want to group these softwares into different types. So if we have software, we just simply want to group them into different types. Something like Microsoft Word, it helps us to type in things. They are for general purpose stuff. Everybody can have access to Word, and then it's not you can make use of it. Things like spreadsheet, Excel, they're for general things, right? It's for everyday use stuff, right? And then we have some very specific software. So something like software, if we can buy a software that allow us to manage people, for example, or to manage the human resource of an organization. It's specific, it's mostly for managing human resource. But if we look at Word, we can insert images and other things we can use for presentations, very general stuff. So we've already set some differences. So we have the generic one and we have the specialist one. Then on top of the specialist one, we actually have one called the bespoke. So the bespoke one, for example, if we go out to ask someone to design a software for us, and the software we give them our requirements. So let's say software for the university, specific for student attendance, and just the university have requested. We have students coming from this number of countries. We have students coming from Kerala, for example. We specifically want translation into one of the Indian languages, especially one that is strongly spoken by people from Kerala. We can talk about some maybe things like we want it to automatically take attendance. We want it to recognize Northamptonshire, for example, or we want it to recognize the locality. It's very specific to what we want or what we are requesting for. So it's bespoke. Normally, it gives us high performance for what we have designed it for. So even though there may be some other student management software for some universities that everybody is using, because we've tailor-made this one, it fits us better. It doesn't necessarily mean it fits everybody better. So my size of clothes, if it's tailor-made to fit me, does not necessarily mean it will fit another person even who looks almost like me, right? So we've got a specialist. It's still somewhat everybody can use. It's specific, it's a child management software, everybody knows, but it's not necessarily tailor-made for a particular company. So I've got a question standing by that's asking for a SIM card. I'll throw it back to you now. Can you hold a SIM card in your hands or fingers? Is that hardware or software? Good, that makes it hardware. Perfect. Yeah, so like I said, even if you open the device, the things you can physically touch is hardware. In the digital world, in the ones and zeros world, that is software. Does that make sense? Good. Thank you for asking. So bespoke, think of it as tailor-made, right? So you've got everybody can use Word, maybe some general architects, even like computer world engineering, they have things like MATLAB. Everybody will use MATLAB, right? It's a software, and then it has this programming language. Or even if you go to things like Blackboard, everybody use Blackboard. Or Moodle, everybody use Moodle, right? You get another company can buy Moodle. Maybe they can customize it. Okay, great. But let's say the university decides we want our own software, these are our requirements, then we have the software designed for us. So it's like basically I'm going to a tailor to say, I want a suit, they measure my size, they get my requirements, they make it for me. And I say, no, I don't want this part on that side, I want this on here. So it's designed according to my taste. The same way software designed for a company that's gone with their own requirements to say we want this to be designed that way, that way, that way, so we can use it to improve the performance of what we are working on. Does that make sense? Or do you want me to rephrase it? I'm looking at the response to the person that asked the question in the chat window. And he's gone to sleep. Okay, we continue. Right. Thanks for responding. Okay. So we're talking about weaknesses. Okay. Basically, systems fail. We know that. Even network fail. People have lost connections and other things. And of course, you may have some things that may not necessarily fit together. But let's go into how to fine tune system, like troubleshooting things or try to reduce that kind of risk as much as possible, right? So mainly you have to train your people, make sure people know what they are doing, and provide regular training. So it's not one-off training and that's it, right? And make sure that the information or the data that you are dealing with is as accurate as possible. So one, right, providing right training, the data you are dealing with or storing is as accurate as possible. And I'll add within legislation as well also. And make sure you upgrade software and hardware easily, regularly, not easily. If you are still using very old software, you are likely to even get more viruses anyway, because people would have figured out how the system works from time to time. Make sure you add new hardware to improve the efficiency of your system. And of course, use criteria, go through a standard, proper evaluation criteria to decide what software or hardware to buy. And we've already gone through the steps in the previous slides as well. So let's fix something right now. Who do YouTube reviews tend to use benchmarking a lot, or reviews of various devices coming out on their social media and other things. So benchmarking simply means that what is the standard point of reference, right? It's like if they say someone is super smart, so how? Like, how do you know the person is smart? And then they say, okay, IQ. And they say, which IQ test? And that IQ test. They took this IQ test that maybe Einstein took and got this much, then they got better than Einstein or something. It's just a common point of reference that normally is agreed or accepted but as the standard reference. Okay. So we go through a standard test. So benchmarks are standard tests that allow us to assess how well a particular type of software actually works. So how good is this person? Yeah, how do you know he's good? Or like relative to these people, or really everybody agree that this is the standard. Everybody agree that Usain Bolt is the fastest person. Why? Because by Olympic standard, he holds the fastest records. Good. So we're going to see a typical test of a printer might be maybe how long it takes to print. We've made several references and other things. So advantages of benchmarking, obviously, get cheap advice, easy way to assess or compare some things in terms of a suitability of a product. So how good is this product? The disadvantage is that it may include a lot of information that's not necessary. I just want to see how fast I am. I don't need to go to Olympics or try to set up a proper world track to see how fast I run against Usain Bolt, for example. So typical example, you've got how much these printers can print. So you've got a laser printer being compared to an inkjet printer, and then the other being compared to a dot matrix. And according to this standard, the inkjet printer printed 1, 2, 3, as many of them. So it turns out to be the fastest. Also, it got the best, and then the next one was the dot matrix, and the last one was the inkjet. Good. Yeah, it looks like I've written on the screen. But then we're going to do something similar. I'll ask the questions and then you will answer to find out where this red thing is coming from. Don't know. So I'll read through the questions really quickly. Question number 1. Are we ready? Are we ready? Good. Question number 1. Before setting up a new or replacing an old system, what should be performed? What's the first thing to do? Is it system investigation, system development, or system analysis? Oh, people have been awake. I'm going to try not to answer the questions or confirm. Question number 2. Which of these is the correct order to perform things? By perform things is the same as the first question, right? Is it A, analysis, design, implementation, and evaluation? Or is it B, implementation, design, analysis, and evaluation? Or is it C, evaluation, analysis, implementation, and design? If you got the first question correct, you should be able to even look at one word and get the second question correct, right? Question number 3. What document is produced to identify whether the project is technically possible and worth the cost of development? Is it A, analysis report? Is it B, feasibility report? Or is it C, profit and loss report? And there was silence. Should I continue? Do you have your answers? Okay, some people have been awake. I said I'm not going to confirm the questions, but you're doing well. Question number 4. Which diagram would be used to show the flow of data around the new system? Is it design diagram? Is it system diagram? Is it data flow diagram? Something for you to think about. You can't see the question. Can I read it again? At least it will help. Question number 4. Sorry? Maybe it's from your side. Other people should be able to see. Okay. All right. So can I continue? I'll read for you again. Which diagram would be used to show the flow of data around the new system? Is it design diagram? Is it system diagram? Is it data flow diagram? Good luck and fight over it. Okay, right. Okay, so uh, well, that's what is paying attention. Can I continue? Question number 5. Observation, interviews, questionnaires all take place during which stage? Is it A, design stage? Is it B, evaluation stage? Or is it C, analysis stage? Design, evaluation. Question number 6. The input, processing, and output from a new system will be identified in which document? Is it A, requirement specification? Is it B, system report? Or C, analysis specification? You may want to do a bit of reference for that. Question number 7. What needs to take place to make sure a newly developed system works correctly? Is it A, testing, B, designing, C, backing up? Question number 8. Which document would contain instructions and screenshots to help people understand how the new system works? Is it A, user document, B, user reports, or C, user specification? And there was silence. Question number 9. Question number 9. What is running the, what is running the old and new system alongside each other known as? That question we will talk about it in the next presentation, okay? But anyway, think about it. Is it direct changeover, twin running, or parallel running? If it will come back at some point. Okay. So it means we don't have to cover the new slides then. Is question number 10. Which stage checks that the system does what it's supposed to and is working correctly after installation? Is it the implementation, analysis, or evaluation? Are you sure? Okay, well done to all those who have been awake up to this point. Let me see. Oh, there is more. Huh, wait. Let's do it. Let's do it. Yeah, let's do it. Let's do it. Let's do it. Let's do it. We've got 10 more questions. I'll read through it really quickly for you, okay? As soon as I finish, you pick your answer. I'm going to go on. What is the general purpose of software such as word processor and spreadsheets known as? Is it bespoke, generic, or specialist? The answer is in the question. The answer is in the question. Question number 2. What is the software that performs the specific role? Hmm? What was it? Okay, question number 3. What is software developed to do specific tasks for a company? Known as. Good. Question number 4. Sorry, I shouldn't be saying good. I stopped giving feedback. I should discipline myself. Changing hardware or software will probably mean you need to do what? Sack people, retain people, promote someone. I don't like that question. Can I continue? I'll just cross that question out. It's not the best question on the screen. Yeah, but I don't like the question. Yeah. Can I continue? I should revise that. Question number 5. Should be 5. Which of the following is needed to decide which new hardware or software to purchase and how it will be used? Is it A, system investigation, B, evaluation criteria, or C, hardware investigation? Question number 6. When buying a new hardware or software, which of the following is most important? Check staff already know how to use it. B, check what is compatible with, whether it's compatible with existing hardware or software. Or is it C, check that it has user manual? Question number 7. Which of the following criteria is not important when deciding what software to purchase? Ouch, my neck hurt. Right. Large selection of fonts, B, end user needs. And sorry, what was it? Question number 8. What term? Sorry, am I? Are we okay with the pace at which I'm going, or am I going too slow or too fast? Let's say we are okay. Somebody say we are okay. Good. Question number 8. What term is specifically used to describe software that works well and doesn't crash when used with different hardware and software? Is it reliant, unreliable, or robust? Are you sure? Look it up. Well, question number 9. what are standard what are standard tests used to assess software and hardware? Compatibility tests, benchmark tests, comparison tests. You should get this easily. Question number 10. What is changing the settings of a piece of software to suit you, also known as adapting, customizing, altering? What was it? And that takes us to this guy. Let me see how many minutes he is, and we should be close. Be close. Let's get going. I'll get him out. Just bear with me, and another if there's anything to fit in. Right. I think hopefully we should be okay with most of these devices. What is most suitable input device for inputting a short report? So, I said I would discipline myself. What is the most suitable input device for highlighting or selecting an object on the screen? I'm doing it right now. Good. Not the one that will make you scream, the one that comes with a computer. Okay. Which of these would you use to digitize a paper photograph? Yep. And now you can even use your phone to take the photograph, right? Yeah. Um, what is magnetic ink character recognition often used for? It's, yeah, really good. Which of these would you not use on an optical mark reader? Sorry, question completely wrong. Well, which of these would not use an optical mark reader? I do apologize. Tied. Is it multiple choice test or voting form or barcode? Figure it out. Right. Which of these is another name for CPU? This one I would say I like. Which of these is not a type of computer monitor? Oh, good. Good. I don't have to write it down. Question number 8. Which of these printers would you use to print a wage slip? On a carbon paper. So think about a printer that makes use of carbon paper. The inkjet, the laser, dot matrix, figure it out. And again, more questions on printers. I'll use more different questions on hardware. I think printer questions normally these days, printers are becoming more common and popular. Anyway, let me read them out. Which of these printers would an architect be most likely to use to print large plans? Not my favorite type of questions. Question number 10. Sorry, answer it, by the way. Yeah, all on inkjets, laser jets, and it's just about use cases of them. Question number 10. Which of these printers would be most suitable for printing a large number of high quality black and white printouts? Now, let's do something. I say it, you say whether input or output device, right? Mouse, mouse. Monitor. Okay, touch screen. Input and yeah, because once you touch, you see the feedback straight away. Keyboard, joystick. Joystick is an input. So camera, camera. I, I heard someone say, huh? It depends because if you're just talking about the actual lens capture, maybe just going as an input. If you're talking about a camera device that is both touchscreen, then you're looking at both getting some feedback in there as well. Okay, so this is the point where, oh, there is more questions. Shall we do more questions on that? Which of the following retains, we almost done. Which of the following retains its data even after the computer is switched off? Is it ROM, RAM, or RAM? Which RAM stands for random access memory. ROM stands for read-only memory. RAM is just made up. Which of these do you think after you switch off the computer and switch it on, you still get the data stored? Is it read-only memory, random access memory? So random access memory is normally like it's like a playground, right? So basically, the computer fetch information from the permanent one into here, and then from there to the processor for the processor to work on it, right? But the random access memory is actually volatile. This is why I'm covering these questions so I can use it to give you information. Because it's volatile, it means when you cut the power to the computer, you will lose the data. But normally the information is coming from things like a CD-ROM. CD-ROMs are outdated, like hard drive, um, like you've got different forms of memory. And some of the memory, of course, it doesn't like ones that contain the actual code that works with it. You want it to be read only. You don't want it the user to mess up with it. So even if you cut the power, the information will be stored. So is it read only memory, RAM or RAM? RAM. Good. What does RAM stand for? Why did I just answer it? Okay. What is a computer's main internal memory? Internal backing store. Okay. How best is the size of a hard disk measured? I'll go for this time, the gigabytes. It actually depends on what time frame you're looking at. What type of media is a hard disk? Is it optical, magnetic, or solid state? Oh, whoever said that, you deserve chocolate from me. Luckily, I'm eating online, so I can't pass you chocolate. Right? So, who was the first person who answered it? So, if you ever see me in person on campus or anywhere, just remind me I owe you chocolate. There are a lot of you. Don't come and say I owe everybody chocolate. you had you hunt me down. All right. Which of these is an example of an optical storage device? Are you sure? Okay. What does DVD stand for? I don't see A as an option there. Whoever answered what question number 8. Which of these storage media would be most suitable for backing up school file server overnight? You want to go for one with that? Yeah, but even this, I'll just choose cloud. This question is outdated. I'll go for it. You know what I mean? Um, Question number 9. What would be the most suitable device to transfer files from home to school? Magnetic tape, hard drive, USB. Good. Which of the following shows the correct order of storage size starting from the smallest to the least? Some of these are outdated, so basically you just go for one with the highest on the background. Right. Sorry, did I sort of preempt your answer to the question? You can think about it anyway. And finally,